right, so graphing a function, okay? Let's look at this first example. We're going to graph f of x equals 7 minus 2x. Okay, so we need to identify our parts. If you don't understand where to identify our parts, this is my function rule. Okay, this is going to be my output. All right, so the first thing we're going to do, so our step one here, we're going to create a function table. Okay, so my function table, I'm going to have, and again, I'll color code them like we have been. I'm going to have inputs, and our inputs for this particular problem are going to be 7, 5, and 3. We're going to have our function rule here. Okay, so my function rule, and remember, what is our function rule? My function rule is whatever is right here after this equal sign. So my function rule is f of x equals 7 minus 2x. We're going to have outputs, and then we're going to have our points to put on our graph. All right. So then step 2, we're going to substitute inputs into function rule to get our outputs and points. Okay, so for my function rule, I'm going to use my parentheses where my x is. So it's going to be 7 equals, not equals, I'm sorry, minus 2 parentheses. What goes inside the parentheses? Whatever my input is, which is 7. And then we're going to solve that. So 2 times 7 is 14. So I get 7 minus 14. And what is 7 minus 14? That's going to give me negative 7. And that will be my coordinate point. So my first coordinate point is we have 7, negative 7. And we do it for the next two. So if you want to work ahead of me, try to fill those in, see if you got it right, go for it. If not, you can follow along. So 7 minus 2 parentheses. What goes in my parentheses? Whatever my input is, 5. And that's going to be 7 minus 2 times 5 is 10. So then 7 minus 10 is going to give me negative 3. So my coordinate point here is going to be 5, negative 3. And the last one, 7 minus 2 parentheses, my 3 goes inside of here. 2 times 3 is 6, so 7 minus 6, which is positive 1. So my point would be 3, comma, 1. All right. So all you're doing is you're subbing this into your parentheses here, and you're solving it because this is an equation. You can solve it like an equation, and then you get your output. And step 3, well, we're going to plot the points on a graph. Plot the points on a graph. All right. So for this particular graph, I know my biggest point is 7. And then for my y, my x's will go to my x's will go 7, my y negative 7. So we'll just make this graph to go 8 to negative 8. And we're going to count by 2s to kind of make it small here. So let's see if I did this right. So it will be 8, 6, 4, 2, 0. Oh, I didn't. 2, 4, 6, 8. We'll extend that a little bit. So negative 8, negative 6, negative 4, 2, 0, 2, 4, 6, 8. So I just need 1, 2, 3, 4. 1, 2, 3, 4. So negative 8, negative 6, negative 4, negative 2, 2, 4, 6, 8. I'll give you guys a second to get that drawn up. So all we do now is we just plot our points from right here. So I got 7, negative 7. So I go over 7, down 7, because you do x then y. Then I have 5, negative 3. So over 5, down 3. And then we have 3, 1. So over 3, up 1. And once you do that, try your best to make a straight line. And that is graphing our function rule. So all I did was plot my points. So this was 7, negative 7, 5, negative 3, and 3, comma 1. We plotted our points, we drew our line, and that's graphing a function. So just to review, we took our function rule, put it in our function table, did our input, got our output, made a point. All you're doing is you're substituting this value in here to get this value. So it's basically like saying, here's your equation, all right, what's y when x is 5? You plug 5 into x, solve, okay? Here's your final answer there.